A transparent glass slab of thickness 0.5 centimeter is placed with its face AB on a horizontal table. This is face AB. A hemispherical water drop of radius capital R equal to 0.33 centimeter condenses on the glass slab as shown in the figure. So this is the drop, radius 0.33 centimeters. The refractive indexes of the slab and the water drop respectively are 1.5 and 1.33. So slab is optically denser than water. The image of the object O, or the image of the object at O, object is here, on the face AB, object is on the face AB, is viewed after refraction from the drop, taking OEQ as the optical axis. Okay, taking OEQ, this line, as the optical axis. The distance in centimeters of the image from the point Q is, okay, 1.4, 0.6, 0.72 and 2.00. Well, clearly this object, okay, the rays that come out of the object, they will undergo two refractions, one at the interface of water and glass and the other one at the interface of drop and air. Okay, what I did, okay, let's first go to figure. Okay, let me explain the figure that I've used to solve the problem. Look, O is our object. Okay, O is our object. OG is our first ray. Okay, OG is our first ray. Then this ray will undergo refraction. This ray will undergo refraction at the water glass interface and we will get the ray GH. Okay, so this ray GH will be in water. This is in glass. Okay, and then the ray GH will again undergo refraction at the air water interface and then this ray, okay, H to that will be our refracted ray in air. Okay, and when this extends, this is extended backwards, when it meets the optical axis at P, that is going to be the image. Okay, that is going to be the image of object O. Okay, object O viewed from drop, viewed from above the drop, let's say above the drop. Okay, viewed from above the drop. Now let us consider the angles. Alpha is the angle of incidence at water glass interface. Okay, water glass interface, that is angle alpha. Okay, then beta is the angle of refraction. Okay, beta is the angle of refraction at water glass interface. Then gamma is the angle of incidence. Okay, gamma is the angle of incidence at water air interface, and then delta is the angle of refraction. Delta is the angle of refraction at water air interface. Okay, so we have got these four angles: alpha, beta, gamma and delta. That's the notation that I have used. Okay, I hope you are clear with the notation, right? I have called this center of the sphere as E. Okay, I have called the center of the sphere as E and the location where the image is formed as P. So basically we want QP now. Okay, we want QP, the distance in centimeters of the image from the point Q. Okay, now look, this analysis is going to take a lot of time if we go for the analytical solution. Okay, because first of all we have to choose an arbitrary angle alpha, or even if we don't choose arbitrary, then it will get further complicated. So we have to take alpha, get beta in terms of alpha, then use the properties of triangle in the triangle GH this, so express gamma in terms of beta, then apply Snell's law again at gamma delta interface, then stretch it backwards, and using geometry you can get P. So what I did is, I took alpha as 30 degrees. Okay, I took alpha as 30 degrees and did all the calculations. I think I showed those calculations to you. Let me show that to you again. Yeah, so this is the calculation that I did with alpha equal to 30 degrees. Okay, alpha equal to 30 degrees. then I got beta, gamma, delta, and finally I managed to get that distance, and that distance was 2.96, which was never close to these options. Okay, it was even greater than D, 2.00. Okay, and well, I knew the option given in the official answer key is A. Okay, so then what I thought was building a model which replicates the actual situation, and what I found out is very surprising. What I found is with change in the angle of incidence, we will get the image at different locations. So here is that animation for you. So this is the animation. Let me increase alpha. Okay, now let me explain this. The green semicircle is our drop. Okay, the green semicircle is our drop, and as you can see at point A, okay, point A is at negative 0.5, so that basically covers the thickness of the plate, the thickness of this block, which is 0.5 glass slab. Okay, 0.5 centimeters, that's the thickness. Okay, and then from A there is a ray that is going to come out. It will get refracted at B. So red ray is in water drop. Okay, you can see that slightly bending away from the normal because it is from optically denser to rarer medium. And then from H, okay, from H, sorry, not from H, at C, at point C, if you look at the pink ray represented by equation 1, that has now bent away from the normal. Okay, that has bent away from the normal because again it is traveling from optically denser medium to optically rarer medium. And then when this ray is stretched backwards, when it is allowed to meet the y-axis, which is of course the optical axis, okay, optical axis, that is our location of the image. Okay, so if we measure D, okay, if we measure D from the top of the drop, okay, if we measure it from the top of the drop, that is Q, so we would like to measure it from this point, okay, where the drop meets the y-axis, that distance. Okay, so what I have done is at the end here you will find the distance. Okay, so at 22 degrees it is 1.66. Okay, now look how significantly it changes if I change alpha. Okay, now it is 2.33, and you can clearly see the drop, the image moving downwards. Okay, at 30 degrees it's 2.85, which fairly matches with what I got here. Okay, with the answer that I got, I got it as 2.96, maybe due to the approximations that I used, but or even GeoGebra sometimes rounds it off to 2 decimal places. That's fine. So that's 2.85. But surprisingly, let us decrease alpha now. Let's decrease alpha. Okay, keep an eye on the angle or on the distance. Okay, look now. The moment it becomes around 9 degrees, or let's say from 10, it hovers around 1.4. Now this is alpha equal to 10. Okay, this is alpha equal to 10, and as I decrease it, it doesn't change much. Okay, so which means they should be using, or they want us to use a small angle approximation, which we used in that variable refractive index problem, right? And now you can see that the answer matches with their answer. Okay, 1.4, the expected answer, which means here we had to use the small angle approximation. Okay, here we have to use the small angle approximation. What does it mean? Small angle approximation means what we call linearization. Okay, small angle approximation means we call it linearization if we consider only till the first degree terms. If we consider the second degree, then it becomes quadratic. In that problem, variable refractive index, that asked us to consider till quadratic. Okay, so for sine theta, the linearization is just theta, because its Maclaurin expansion is theta minus theta cube upon 3 factorial plus theta raised to 5.5 factorial and so on. And for cos theta, it is 1 minus theta squared by 2 factorial plus theta raised to 4 upon 4 factorial and so on. Okay, but now because of the linearization, now how did I conclude that? There is no way to know it. By the way, there is no way to know it. Only through GeoGebra, and because I know the answer, the official answer key, I concluded that. Okay, so that's the deduction that I have made. So small angle approximation needs to be used. So sine theta is approximately equal to theta. So wherever in our calculation sine theta will appear, we will replace it by theta. Okay, and wherever in our expression cos theta appears, we are going to replace it by 1. Okay, that's the key learning that the animation told me. And under this approximation, now we can go back to the figure and get the job done. Okay, look here how that approximation works. Let's consider part 1 of the solution. Let's consider part 1 of the solution. Okay, let us apply Snell's law. Okay, let us apply Snell's law at glass water interface. Okay, let us apply the Snell's law at glass water interface. As told earlier, sine alpha by sine beta is equal to now. So it's 4 by 3 upon 3 by 2. 4 by 3 is of water, 3 by 2 is of glass. Okay, it's always in the numerator you write the refractive index of the medium in which it is refracting. So 4 by 3 upon 3 by 2, that's 8 by 9. And here we have used that linearization. Here we have used that linearization, meaning sine alpha has been approximated as alpha and sine beta has been approximated as beta. And similarly, in part 2, if we apply the Snell's law at water air interface, then we will get sine gamma upon sine delta as 1 upon 4 by 3 or 3 by 4. Again use linearization, so gamma by delta is approximately 3 by 4. Once you get these relations, then the job becomes easier. Okay, then the job becomes easier. Part 3. See, now eventually at some point we have to bring in the distances because we want to find how far would P appear when viewed from the top of the drop or for smaller angles. Okay. Okay, now consider triangle OGE. Consider triangle OGE. This angle will also be alpha, alternate angles property, right? So what is sine alpha? Sine alpha or tan alpha, okay, in this case tan alpha will be equal to Eg upon OE. So again tan alpha's linearization has also been used. Tan alpha is approximately equal to alpha. Okay? Okay, so if tan alpha is Eg upon OE, I can approximate alpha as Eg by OE. But how much is OE? The thickness. Thickness is half. Okay, thickness is half centimeter given in the problem. Thickness is half centimeter given in the problem. Use it there. Use it there. Okay, use it there to get Eg as alpha by 2. Okay, Eg, the length of Eg as alpha by 2. Okay, now we need to consider triangle EGH and apply sine rule. Okay, we need to consider triangle EGH and apply sine rule, but in what form? Pay attention. Side opposite to EG is gamma, side opposite to EG is gamma, and side opposite to this angle. Which angle? This one, which is beta plus 90 degrees. Okay, beta plus 90 degrees. This is beta and that 90. So side opposite to it is EH, which is the radius of the drop. Okay, radius of the drop. So Eg upon sine gamma is equal to EH upon sine 90 plus beta. I hope you got that. But again use linearization. So wherever sine gamma is there, put it gamma. Whenever sine 90 plus beta is there, now look here. Sine 90 plus beta is cos beta. But as I told you, cos beta linearization 1. So that will give us an approximate value of gamma as alpha by 2 into 0.33 or alpha by 0.66. And what is delta? Delta is 4 gamma by 3. Okay, delta is 4 gamma by 3 and that gives us this from this one. Okay, have you understood till the third part? Okay, alpha, beta, gamma, delta, alright, fine. Now let's go to the next one. Okay, let's go to fourth point. Okay, let's go to fourth point. Now here I consider triangle PEH. Which triangle? This triangle PEH. Okay, this triangle. not the right angle triangle, so to speak, this triangle. Okay, that. Okay, again I apply sine rule there. Again I apply sine rule in that green triangle. Okay, how to apply sine rule? Look, this time this angle is delta. Which one? This angle, because it is vertically opposite to the angle of emergence, delta. Okay, so that angle delta sine will go in the denominator of P, right? Again sine rule. Again sine rule. PE by sine delta is equal to EH upon sine angle EPH. Okay, so I consider this angle EPH. Okay, because EH is actually the radius. Okay, EH is actually radius. So I did that. And then we consider the fact that sum of all angles of a triangle is 180 degrees or pi radius. Okay, so EPH plus PHE, okay, that is delta, plus PEH, that is equal to pi. All our focus is now on finding EPH. Okay, because that will somehow help us in finding PE. Okay, fine. So EPH is pi minus delta minus angle PEH. Okay, pi minus delta minus angle PH. Now if we come to angle PEH, okay, if we come to angle PEH, we know that it is pi by 2 plus HEG. Look here, what is PEH? PEH is this whole angle. Let me use yellow color now. Okay, PEH is this whole angle. This is 90. Okay, this is 90, which means 90 plus beta. Okay, well not beta, sorry, not beta. 90 plus that particular black dot here, we can obtain it by subtracting gamma and 90 plus beta from 180. Okay, we have done that. Okay, so first of all, it's pi by 2 plus HEG. And what will HEG be? Now again let us go to that triangle HEG or EGH and find HEG there. Look, HEG plus 90 plus beta plus gamma is 180 degrees. Okay, let me repeat. Triangle EGH, this triangle. The dotted angle that we want plus this angle 90 plus beta plus gamma is equal to 180 degrees. So based on that we can obtain the angle HEG. Pi minus gamma minus 90 plus beta or pi by 2 plus beta. So essentially we get HEG as pi by 2 minus gamma minus beta. Okay. And now we can go finally back to EPH, which was pi minus delta minus that angle, pi by 2 plus HEG. HEG has been now obtained. HEG has now been obtained, so we can happily substitute it there. Okay, happily substitute it there. Pi will get cancelled. Pi by 2 minus pi by 2 minus pi by 2 will get cancelled, and finally we will get EPH as gamma plus beta minus delta. All this is possible only because we approximated sine as that angle and cos as 1. Okay. Okay, next part. Have you followed part 4 or shall I explain it again? Okay, fine. So part 4 is done. Let's go to part 5 now. Let's go to part 5. Now, having obtained EPH, okay, having obtained EPH, now let us return to triangle PEH. Let us return to triangle PEH and again apply sine rule there. We already applied it here. Okay, that's one. P upon sine delta is equal to H upon sine EPH, but because we now know what EPH is, it makes it easier to find P. Okay, so P will be sine delta into radius of the drop EH upon sine EPH. Okay, P is equal to EH into sine delta upon sine EPH. What is EPH? Okay, EPH is gamma plus beta minus delta. EPH is gamma plus beta minus delta, and we can approximate it as this. Delta was already there. EH, we know its value, and now remember alpha is not here. Okay, in these angles alpha is not there, but can be brought in. So use whenever we see delta, use its expression for alpha, and that's the reason we got them in the first few parts. Beta is 9 alpha by 8. Okay, beta is 9 alpha by 8. Beta, right? Beta is 9 alpha by 8. What is gamma? Uh, what is gamma? Gamma is alpha by 0.66. Gamma is alpha by 0.66. Gamma is alpha by 0.66, and then finally delta. What is delta? Delta is 4 gamma by 3. I have obtained it there in terms of 4 alpha by 1.98. And then alpha goes, you calculate. See, still that is not the answer, okay? That is only PE. What we have found out is only PE, which is 1.075. Okay, PE is 1.075. And then when you add radius to that 0.33, then you finally get it as 1.405. That is option A. Okay, because look, P to E was obtained, so this distance is 1.075 approximately, and then plus this radius. If you add that, that makes it 1.405, and that matches pretty well with the option.